Hello, mathematicians. Today we're going to be learning about compound inequalities using AND statement. And when we use the AND statement, it means that our x value has to be true for this inequality and this inequality. So let's start off by isolating x in both of our inequalities. Here I have negative 7x minus 50 is less than or equal to negative 1. So the first thing we do is we add 50 on both sides. And this way our negative 50 or minus 50 cancels out with the positive 50. And I'm left with negative 7x is less than or equal to 49. And here, in order to get x by itself, because this is multiplication, I do have to divide by negative 7 on both sides, because that's the inverse operation. And negative 7 divided by negative 7 is 1, so that cancels out. And here I'm left with x. Remember that when we multiply or divide by a negative, our inequality symbol flips so that it could stay true. And 49 divided by negative 7 is negative 7. So here I have x is greater than or equal to negative 7. Let's do the same thing on our other inequality. So negative 6 plus 70 is greater than negative 2. In order to get rid of our plus 70 or positive 70, I have to subtract 70 on both sides of the inequality. And this cancels out our positive 70. So we're left with negative 6x is greater than negative 72. And now, in order to get rid of our negative 6, we have to divide both sides by negative 6. That cancels out. Divided by negative 6. And remember again, when we divide or multiply by a negative, our sign flips. And negative 72 divided by negative 6 is positive 12. So let's graph this and see what happens. So somewhere here, I'll plot my negative 7. I'll plot 0 around here, and then 12 to the far right. So here, for x is greater than or equal to negative 7, negative 7 is included, so it's a shaded circle. And because x is greater than, we're going to shade to the right. And I'm going to try to shade that as straight as possible. Okay? And now for our second inequality, x is less than 12. 12 is not included, so it's an open circle, and because x is less than, we shade to the left. Now here you'll notice that our inequalities are shaded in two opposite directions. And if this were an OR statement, it would be all real numbers. But our AND statement needs to make sure that whatever our x value is true for this inequality and this inequality. So with that being said, we could see where they overlap because it has to be true for both. In both cases, negative 7 is included, and 12 is not included, but it's where inequality ends. So here, negative 7 is the smallest number that can go into our inequalities and make it true. So negative 7 is greater than or equal to negative 7, and negative 7 is less than 12. And since this is the smallest one, we write it first, and it's going to be the smallest, so it's less than or equal to x, because our x is everywhere in the middle between negative 7 and 12, including negative 7. It does not include 12, because although 12 is greater than or equal to negative 7, it's not less than 12, so we can't put the equal sign here. So we'll write 12 after. And what this basically means is that x is everything in between negative 7 and 12. Because if you substitute any number in these two inequalities, with a number between -7 and 12 or -7, because this is equal to, that would make it true. For example, the number 10 is in between these two numbers, and 10 is greater than or equal to -7, and it's also less than 12. -7 is included only because of the equal sign. And then let's say -6. -6 is greater than or equal to -7, and it's also less than 12. Okay? So this x is everything in between these two numbers, including -7, but not including 12. Let's look at another example here, and we're going to start off the same way where we isolate for our x value. So the first thing we need to do here is subtract by 3 on both sides. And divide by -8. So since we're dividing by a negative, we'll flip the sign. And 24 divided by -8 is -3. And we'll do the same thing with the following inequality. So the first thing we do is we subtract 5 on both sides. Cancels out. -13x is greater than or equal to 52. And here I need to get x by itself, so we'll divide by 13 on both sides. -13 cancels out. X is less than or equal to -4. And so here we have x is less than or equal to -3, and x is less than or equal to -4. And remember that our x value needs to be true for both, so let's see where they overlap. So here, what I'm going to do is I'm going to plot -5, -4, -3, -2, -1, and 0. So for our first inequality where x is less than or equal to -3, because it's also equal to, it's a shaded circle because -3 is included, and it's less than, so we shade to the left. Okay. And then for second inequality, we have x is less than or equal to -4. And again, -4 is included, so we're going to shade in -4. And because it's less than, we also shade to the left. And remember, here we're dealing with our and statement. So our x value has to be true for both. So here, if we look at where they overlap from -4 to the left, because anything less than or equal to -4 will be true for both of these statements. Even if we look here, it overlaps with the blue exactly, starting at -4. And because this is a shaded circle in -4, we have to include the equal to. So in this case, x is less than or equal to -4 because all values, including that are less than and including -4, make these two statements true. Because it's an and statement, it has to be true for both. And this is the only way that it will be. So let's look at another example here. So we're going to start off the same way, and we're going to isolate our x. We're going to start off by subtracting 60 on both sides of the inequality. This cancels out. And here we're left with -15x is less than or equal to 45. And we're going to do the same thing. We're going to divide both sides by negative 15 because we want the x by itself. These cancel out, and I'm dividing by a negative, so I switch my inequality to greater than or equal to, and 45 divided by negative 15 is negative 3. So here, x is greater than or equal to negative 3. So let's do the same thing for our second inequality. We have 14x plus 11 is less than or equal to negative 31. So let's start off by subtracting 11 on both sides. And we have 14x, this cancels out, is less than or equal to negative 42. So here, we'll divide by 14 on both sides. Because we're dividing by a positive, we do not need to flip our inequality. So x is less than or equal to negative 3. So let's plot this and see how it looks on our number line. So we have negative 3 in both of these inequalities. So I'm going to put negative 4, negative 3, and negative 2 on our number line. And for our first inequality, x is greater than or equal to negative 3. So negative 3 is going to be shaded in. And because it's greater than, I'm going to shade to the right. And for second inequality, I have x is less than or equal to negative 3. So again, negative 3 is shaded because it's included. And because it's less than, I'm going to shade to the left. Now remember that this is an AND statement, meaning that the x needs to be true for both. And the only place where it overlaps is here at the negative 3. So they're both equivalent to negative 3, but our inequalities go in opposite directions, but they both include negative 3. So in this case, x could only equal negative 3 for it to be true for both statements. For example, if I put 2 is greater than or equal to negative 3, it's true for this inequality, but not for the second inequality. Negative 3 is the only number that we could substitute x for, and it'll be true for both. So here we have another example, and we're going to do the same thing. We're going to get x by itself. So by isolating x, we have to first subtract by 44 on both sides of the inequality. Negative 8x is greater than or equal to 16. And divide by negative 8 on both sides to get the x by itself. Cancels out. X is greater than or equal to negative 2. And let's isolate x for second inequality. So first thing is we subtract by 50 on both sides of the inequality. Cancels out. I'm left with negative 4x is less than 8. So in order to get x by itself, I need to divide both sides by negative 4. Oops, I almost forgot to flip my inequality here because I divided by a negative. So this should say less than or equal to. So here I'm dividing by a negative again, and I have to flip my inequality. So x is greater than negative 2. So here I have x is less than or equal to negative 2, and x is greater than negative 2. So let's plot them on a number line and see what we get. So since I'm dealing with negative 2 in both inequalities, I am going to plot negative 3, negative 2, and negative 1. And for our first one, x is less than or equal to negative 2. So I'm going to make sure negative 2 is included. And since it's less than, I'm going to shade to the left. And here x is greater than -2. And it's not included, so I'm going to put an open circle. And since it's greater than, I'm going to shade to the right. Now, because this is an and statement, our x needs to be true for both. And although our inequality overlaps at -2, our first inequality includes -2 and our second one does not. So technically, our inequalities do not overlap at all because one shades to the left, one shades to the right. And here, where one of the inequality includes -2, the other one does not. There's no number that's less than or equal to -2, but also greater than -2. So in a case like this, there's actually no solution.